Welcome to Minute Code Magic. Today we'll explore how different programming languages handle errors. We'll contrast approaches across languages like C, Python, JavaScript, and more, offering insights beyond just syntax and basic examples. C is a basic language with historical significance that influenced nearly all modern languages. We cannot talk about error handling without understanding its history, mainly because C has no built-in handling. It evolved by convention. One technique is it used sentinel values, which are special return values such as -1 used to signal an error. This is acceptable when your function can never return that value. But what about a function like division that returns all possible values of its type? You simply can't use a sentinel, period. One way to solve this, as shown in the second example, uses what's called an output parameter. The parameter named result is a pointer to a shared memory location accessible to both the function and its caller. This works, but it's awkward and not functional. Another method is using a struct with multiple values, such as error and result, which the caller can examine to determine if an error occurred. The advantage of this approach is that the function remains purely functional. Again, these techniques evolved strictly because of C's lack of built-in error handling. In Go, errors are handled explicitly by allowing functions to return multiple values, which is a built-in language feature. Without getting pedantic, this is a purely functional approach and considered the standard way of handling errors in Go. You can see the similarity with C when returning a struct with multiple values. Go is another extremely simple language, but it's 40 years newer. There's not much more to say for Go, because this is a great approach and has done the community well. In contrast, Python uses try-catch exceptions, which do interrupt the control flow, representing a non-functional way of handling errors. For better or worse, many languages of the time popularized the try-catch method, including C++, Java, and more. In Python, like Go, the community kept this original built-in capability as its de facto standard, even for async code. Given JavaScript's, let's say, captivating history, it becomes quite fascinating from a historical standpoint. Traditionally, JavaScript used try-catch exceptions similar to other high-level languages of that era. However, as async programming became prevalent in browsers, programmers encountered challenges. For example, set timeout doesn't propagate errors. As illustrated in the code example, the catch block would not execute in this scenario. To manage async functions, programmers adopted callback functions. This led to the infamous callback hell, reducing code clarity and maintainability. Here's an example of nested callbacks, showing how quickly things can become messy. However, the approach is purely functional, and you can see the motivation from C and the similarity to Go. The key point here is that both the result and the error are returned as parameters in the callback function. With ES6 in 2015, JavaScript introduced promises and the await keyword. This allows for explicit error propagation in async code while writing it in a synchronous manner. This made try-catch a viable way to handle errors once again. Despite the advantages of async await, try-catch still interrupts control flow. Many frameworks continue to propagate errors explicitly, leading to cleaner and more straightforward code like this. In our opinion, this will likely be the de facto way of error handling in JavaScript moving forward. To summarize JavaScript's error handling, it has a rich history of techniques. From try-catch, callbacks, and promises to async await, programmers have continually adapted to improve code clarity and manageability. What's really interesting here, though, is that like Go and Python, JavaScript has a built-in mechanism with try-catch. It's only by the nature of browsers and set timeout that new conventions overcame the limit of the built-in feature. Despite being super high-level and functional, Python's community never migrated away from the built-in try-catch. Explicit error handling is becoming increasingly popular in newer languages and frameworks by default. In statically typed functional languages like Haskell, Rust, and Scala, new data types were added to the type system as built-in mechanisms to handle errors. This is deeply rooted in mathematical theory dating back to the 1930s. The either type, which was wildly popularized by Haskell, is a type that can be one of two different coproduct types, which are polymorphic. The critical point here is that it can only be and must be one of the two types. The either method is still a general concept that ended up being used conventionally for errors. One of its coproduct types, typically called left, ended up being the error, and the other type, right, ended up being the result. However, left and right is just a terrible naming convention. In contrast, languages like Rust have a special result type built in, which functions just like Haskell's either type. Result is considered a special case of either. It has two values, one specifically called error and the other called OK. This is much more clear and domain-specific. The language has a match keyword that can route the flow of control very strictly based on the type itself. You might notice that this is analogous to using structs in C. The difference is that since it's built into the type system, routing the error is no longer manual. In a C struct, you cannot assume that the function wasn't programmed incorrectly and accidentally set both error and result. You have to manually check the error because it's not built in. And, despite being a newer language, this is still how Go works. Let's take another quick look at Python, which is known for being fairly friendly to functional programmers, in which case, it's practically a shame that Python uses try-catch exceptions as its standard. In the first example shown, we can return multiple values like Go or JavaScript. This can already be done in Python using a feature called tuple unpacking, but nobody really does this. Recall that the JavaScript community needed to migrate towards this convention because of their limitations. Lots of frameworks in JavaScript do that as the default. It's their new normal, for lack of a better term. Also, recall that this is Go's built-in de facto way of error handling. Introducing this to Python now is just not a good idea. Don't do this. One main issue is that you have to use none values. But more than that, it's just too disruptive to the existing ecosystem. With Python 3.10, a match keyword was added to Python, in the spirit of languages like Rust, which we saw earlier. This opens the door for Python to implement a built-in functional error mechanism in the future. One key difference, though, is that match in Rust is exhaustive, making sure that all cases are handled at compile time. This is critical to strictly enforce error handling. In Python, the match keyword does not enforce exhaustion. In other words, we can remove the failure case in the second example, and this will still compile and run. That's not good, but it's a bold move in the right direction. So what's the future for Python? Well, there's actually a great library that implements the success and failure method above, called returns. This is equally disruptive to the ecosystem, so I would not use this in any library that you want share publicly. I would introduce this to your own application layer code if you and your team chooses to invest in the technique. In the future, this library can be promoted to the standard library, and eventually Python can build in support for it. A good question is if Python can even support exhaustive matching with a dynamic type system. Let us know your thoughts in the comments. As always, thanks for viewing. Please like and subscribe for more programming tips.